Hi and welcome, ladies and gentlemen. Today we are talking about cycle detection in linked lists. If you don't know what a linked list is, then look up here or up here. So I made a great video about linked lists if you don't know what they are right now. Alright, let's jump to the question, and that is how to find a cycle in a linked list. Well, there are basically two variants. One has a time complexity of big O of n and a space complexity of n, and the other one has a time complexity of n squared but a space complexity that is constant. Well, the difference is that in the first variant we save our nodes in a set. So we have to save all the nodes in the set, that is our space complexity of n, and we have to run once through our whole list that is a time complexity of n. I assume that saving the nodes in the set is a time complexity of 1 and searching in the set is a time complexity of 1, so it is constant 2. Well, and then we have to check for every node when we insert it, or before we insert it, is a node already in the set or is it not? If it is in it already, then we found definitely a cycle. If we didn't, then we can keep going with the next node. Well, in the other one, we have to take a node and we have to compute or calculate the occurrence in the list. And so we don't have to save the node externally again, but we have a higher time complexity for that. Alright, so let's implement that in Python. Well, I have here a created file, and I call that linked list underscore find cycles.py. And for that, I take my linked list that where I showed you the link earlier, where I copy that just. And that is a principle-based linked list where we add list items. And we already create a new list items whenever we add a new value here. But we have to change that a little bit. For that, I want to start with a list item, and I want to put in a constructor that makes us life a little bit easier. Here we say def init, and it gets a self property and a value. And we set here the value is, if we don't give any, none. So we go in here and set self.value equals none. So we don't have to change the previous list that we inserted. So here the add method and everything stays the same. Alright, the next step we have to change is we have to add a node, so we don't create all the time a new list element, because then we won't have cycles at all. So we actually need a method to create a cycle so we can test our cycle detection method. Alright, for that I say def add node, and it gets self and it gets a node by itself. So here we say inserts a node into the list, or better appends. Alright, so what we have to do is we have to ask ourselves, is the node empty for now? Does the anchor exist? So we ask us if self.anchor is equal to none. Then we say here we actually have to ask if the next element is none, because our anchor is initialized here with nList item and will never be none. So we say if the next element of it is actually none, then we say self.anchor.next equals our node that we given. Otherwise, we can go in and then we have to traverse through the list until we are at the end and insert our element there. So we say here our node equals self.anchor.next, which is the first element in our list. And then we say while our node is not empty, or let's say while node.next is not none. Then we go in and say node equals node.next. So we get basically to the last element in our list. And then we say here that node.next equals node. And let me call this not node, let me call this team P node here. And I want this and this and this and this. And I want to call that team P node, because we work there on a different node than the node that we put in. Alright, so like this we can add nodes to our list. Let us try that out quick. For that I have here a list and I want to create now list items. Let me just create 3 list items quick, and there I say node 1 equals, and there we say linked list dot list item, and I give that a value of 1, and I do 3 nodes, and I call this 2 and 3, and here in the end I call those also 2 and 3, and then we print it, and that should work fine. And if we print that, we get none for now. Let's have a look why. Here we say if self_anchor.next equals to none, we say self_anchor.next equals to node. That should be fine. And otherwise we iterate through our list here, and in the print method we say if this is none, we print none. We actually have to add those nodes obviously to our list, so l.addNode, and there we say node 1, and we do that for the others too. So when we print it now, we get 3 times none. So probably because we have to set here self.value equals value, and now it should be fine. Alright, so that works now. So the next step is to find the cycles in our list. So that would basically happen if when we go in here again and we say l.addNode, and let's add node 1. Then we would run into an infinity loop because we always then start at the new node. So if we go in here and say play, then as you see we run into an infinity loop. Let me stop that for now. Alright, that might happen, but we actually want to detect those. So we say def is cycle, and we don't need anything there for now. We go in and say detects a cycle in the linked list, and we say returns true if a cycle exists, otherwise false. Alright, so when we go in there, we take our team P node again and say this is self.anchor.next, and then we go in and say while our team P node is not equal to none, so until we are not at the end of the list, we have a look and say if team P node in, and now we need our set here. So let's create the set, and there I say nodes in list, and there I say simply set at the beginning, if nodes in list. So we want to check if the TMP node is in our nodes list. So then we return true because we found already a circle here or a cycle. Else, then we go in and say TMP node equals TMP node.next. So we go to our next node, and we also have to add our current node to our node list. So we say nodes in list dot add, and we put in our TMP node. Alright, and otherwise if we go through and nothing bad happens, then we can say return false here. So now we can implement that in our add node list. So we go in here and say TMP node equals TMP equals our current node that we want to insert, and then we say if here we say self cycle is cycle. That returns true if there is a cycle. Then we say TMP node dot next equals none. So we set this back to none and let us return false here to make clear that we didn't insert the node. And here we say return true. So we know that everything went fine. So if we do that now, then we shouldn't run into our loop again. So if we go in here now, as you can see, we don't run into our infinity loop anymore. And let me print here the result of the current insertion. So there we see, or there we should see, that we get true, true and true when we insert 1, 2 and 3, and if we want to insert a node again, we get actually false here, and in the end we print the list. Alright, ladies and gentlemen, that was it for today. I hope you liked this video. If you do so, then give it a like. Tell me down in the comments below what you think about the video, and subscribe to the channel to always get informed whenever I'm uploading new videos. Have a great day. Bye.